Year 10, hi. It's a bit late in the day, but we're going to look at simplifying algebraic fractions. It's something you've already done last year, and we're going to build on it a little bit this year. So let's just have a look at what we did last year from Pearson Book 1 on page 187. Okay, do you remember how you would simplify something like this? You would say, right, I'm going to factorize everywhere I can possibly factorize. So I can factorize the numerator because I have a common factor of x in both of those terms. So x is common. X times what gives me x squared? X times x. X times what gives me plus 5x? X plus 5, basically, over x. Does anything simplify here? Yes, it does. I can cancel these two because I've got a multiplication here, and that leaves me with just x plus 5. Let's have a look at another example here. We're looking at the numerator here. We can see there's a common factor of 2. 4 even. The highest common factor is 4. So 4. 4 times what will give me 8x? 4 times 2x will give me 8x. Plus 4 times 1 will give me that 4 over. What's common factor here? I have a common factor of they both divide by 2. 2 times 3x will give me that 6x plus 2 times 2 will give me that 4 here. Does anything simplify here? Well, I can see 2 goes into 4, so 2 into 2 goes once, 2 into 4 goes twice, and I can't see anything else here that simplifies because these are completely different, so I can't cancel them. So I'm left with 2x plus 1 over 3x plus 2. That's my final answer. Okay, let's go down to this one here. On the top, I can see I've got a common factor of x. X times x will give me that x squared, plus x times 8 will give me the 8x over 2x. Here I can cancel this x, and I'm left with x plus 8 over 2, my final answer. Now it gets a tiny bit more difficult. I'm looking at the numerator here. I've got, in terms of the numbers, I've got 2 as a common factor here. I have at least a squared in both terms, and that's it. 2a squared times what will give me 2a cubed? 2a squared times a. I have a minus. 2 times what will give me 4? 2 times 2. This a squared is already outside. I have to include the b because it's not common. I go to the bottom and I notice they both divide by 2, and I've got at least one b in each term. So what's left? 2b times a will give me 2ab minus 2b times another 2b to give me the 4b squared. I then have a look what I have here. I notice that these two are exactly the same. They cancel. The 2 cancels. And that's it. So 1 times a squared times 1 is just a squared over 1 times b times 1 is just b. Final answer. And that's about the size of it. I think let's do this question 5 as well, which is also from last year's things that you were going through. 2m on the bottom is just a single term on its own. We're looking underneath and we see a common factor of m. M times what gives me m squared? M times m plus m times what gives me 2m? M times 2. I look at that and I notice that the m's cancel. So I'm left with a 2 over m plus 2. That's my final answer. Okay, now let's build on that a little bit. This is actually from Pearson Book 2 now. So we're moving into the book we're currently using. We're looking at the numerator. We can see it's a quadratic. We can also see there's no number term. So it's a common factor scenario. We take out the common factor, which is 2. We also have a common factor of x. 2x times what gives me 2x squared? 2x times x minus 2x times what will give me 6x? 2x times 3. We go below here. We notice that this is a double bracket type of quadratic because we have all three terms there. So x times x will give me the x squared. I want two numbers that multiply to give me that 3 and have a difference of 2. Well, 3 is a prime number anyway, so only 1 times 3 will make 3. We want to end up with minus 2x, so minus 3x plus 1x will give me that minus 2x in the middle. We then notice that these two cancel. So we have 2x times 1, which is 2x. And on the bottom, I'm left with just this x plus 1 times 1, which is just x plus 1. We cannot cancel this x with this x because there's a plus in the middle. You can only cancel them if they are multiplied down here. Right, let's move up to here. Do we notice the top? What type of factorization I will do for that? It's a double bracket one. Like so, we have an x and an x. This is a prime number, so again, that's quite cool. It can only be 1 times 2. Has a difference of 1x. So I want to plus 1x, so I want plus 2x minus 1x. The signs are different because that's a minus. On the bottom, did we notice that's a difference of 2 squares? So we have x squared minus 4 is x plus 2 times x minus 2, or if you like, x minus 2 times x plus 2. These two cancel because they're the same, and I'm left with x minus 1 over x minus 2. That's that one. We have another one. We have a quadratic on the top with a double bracket, and we have a quadratic on the bottom with a double bracket. So we go to the top. We'll say let's make a double bracket here. We want two numbers that multiply to give us 10, and when we add them, they come to 7. The numbers that multiply to 10 are 1 times 10 or 2 times 5. We can clearly see that the ones that add to 7 are the 2 times 5. So we have x and x to make that x squared. We have 2 times 5. They have to add to 7. The signs are the same. They are both positive. So positive and positive. We do another double bracket underneath. X and x. Two numbers that multiply to 2 and have a difference, because that's a minus, of 1. That must be 1 and 2. Can't be anything else because it's a prime number anyway. Only 1 times 2 makes 2. So we decide they're different signs, and we want to end up with plus 1x. So we'll put that plus 1 on the biggest one, because that makes 2x minus 1x, which is plus 1x, as we wanted in the first place. We notice here that we have they're exactly the same, so we can actually cancel them, and we're left with x plus 5 over x minus 1. Okay, let's move on to this one here. Question 4. We look at the top, and that doesn't look very nice. But we do notice that they all divide by 2, which means I have a common factor of 2. So I take the 2 out common, and I'm left with x squared plus 6x minus 16. I look at the bottom. Do I have a common factor here? Yes, I do. The common factor is y. Y is common. I'm left with x minus 2. I'm looking at the numerator, and I can see that it can be factorized even further. So I'll make a double bracket here because I can see there are 3 terms in this. X and x. I want two numbers that multiply to give me a 16, and the difference is 6. Is it 1 times 16? Is it 2 times 8? Or is it 4 times 4? It must be 2 times 8 because the difference here is 6. Okay, so I'll put the 2 and the 8 here. There's a difference of 6. The signs are different. I want to end up with plus 6. So I'll have a plus 8 and a minus 2. On the bottom I copy. It doesn't factorize further. I notice that these two cancel out. And I'm left with 2x plus 8 over y.